All right, guys, in this video, I'm going to go over the two free response questions for chi-squared and linear regression. So the first question is giving us this bar chart, side-by-side bar chart, and essentially we're looking to see, is there a relationship or an association between the choice of favorite sport to watch and the gender for the population of students at this high school. So when I read that, right, both of these variables are categorical. All right. And so that means it's going to be a chi-square test. So you just have to pick which chi-square test. And I'm going to choose of independence because of that key phrase, is there an association? Now, in terms of finding the degrees of freedom, right, that formula we use is rows minus 1 times columns minus 1. But it can be a little tricky here because you'll notice that we don't actually have a two-way table. So what you have to do is you have to think about what would the table look like if you were to make it. And you could put the gender on the rows or the columns. It doesn't really matter. But what I notice is I see we have male, female. So I'll put that as 2 rows. And then columns, we have 1, 2, 3, 4, 5 sports. So if you go ahead and multiply all that out, 2 minus 1 is 1, 5 minus 1 is 4, 1 times 4 is 4 degrees of freedom. Now, part B says that the conditions for inference were determined to be satisfied, and they gave us an appropriate test statistic, right? So that's a chi-squared test statistic of 10.77. So if you were to draw that curve, right, remember chi-squared is skewed to the right. And here's 10.77, we're shading to the right. We need to use our calculator to figure out the p-value, right, that area under the curve. So I'm going to use my calculator. And I'm going to go to my chi-squared CDF, which is second vars, number 8. And I'm going to type in the lower value, which is my chi-squared test statistic, 10.77. My upper value is infinity. My degrees of freedom we just calculated was 4. And this will give us the p-value, 0.029. So the p-value is 0.029. And it says at the alpha level of 0.05, is there enough evidence to say that there's a relationship between these two categorical variables? And the answer is yes. 0.029 is below our alpha, so our p-value is below 0.05. So there is an association between gender and favorite sport to watch. All right, so that's it for the first one. Didn't have to actually run any of the stuff, but it gave us a chance to kind of go over a few things that are important about chi-squared. Okay, number 2. All right, so number 2 states that we're trying to figure out if there is an association between the type of ad and the children's choice of snack among all children, similar to those who participated in an experiment. So my null hypothesis, right, in this test is going to be that there is no association. All right, so we're trying to prove that there is one. So we always want to assume that there's not one. So there is no association between type of ad and children's choice of snack. So the alternative hypothesis is the other way, where we say that there is an association. Now you'll notice in this table, right, it's a two-way table. So that rules out goodness of fit. And you could run a test for homogeneity here. I'm going to run a test for independence because of that phrase, is there an association? But it's okay if you decide that this is a homogeneous test, that's fine too. But ultimately, right, since these are both categorical variables, right, of the ad that they watched and their choice for the word of add and their choice of snack, right? None of that is quantitative. Okay, so got a few assumptions and conditions to make here. We're going to assume independence. So 1 kid's choice of snack won't affect others. All right, we do have randomness. It says in the problem that these 75 children were randomly assigned to one of these 3 groups. So 75 children were randomly assigned. Now you could do all of the assumptions and conditions about the sample size, but because this is an experiment, right, it really doesn't pertain here to think about the 10% condition or the large enough, is our sample large enough kind of thing. So I'm not really that concerned about it, but I do need to check one thing that they will take off if I don't check is I do need to make sure that the expected values, all right, are all 5 or more. So I'm going to do the expected values in this table up here. And the way I'm going to do it is I'm going to run the test first, but then kind of ignore all the stuff. So second matrix, and this is going to be my matrix A, and it's going to be 3 rows by 2 columns. So 3 by 2. So that first number is 21, 4, 13, 12, 22, and 3. All right, so now I'm going to run a test. All right, the chi-squared test that's not goodness of fit is just the one that says chi-squared. I put my observed values in matrix A. It's going to put the expected values in matrix B, which is what I care about right now. So I'm going to ignore that for a second and just go back to my matrices. And I want to see what it says for these expected values. So we have 18.6 repeating. So 18, I'll say 0.7 for all of these. And then for the second column, if you go over, those are 6.3 repeating. All right, and what you should notice is that the 18.7 and the 6.3 are both, all the numbers are 5 or more. So all expected values are 5 or more. All right, so our sample size is large enough. Again, I'm not that concerned about it, the sample size, but you need to check the expected values. So now we're ready for the mechanics. And you can, oh, sorry, I forgot, I'm ready for my statement. So the conditions have been satisfied. So I will use the chi-squared model with, and you can do a quick calculation here for degrees of freedom. We said we had 3 rows, right? And 2 columns. So that's going to be 3 minus 1 is 2, 2 minus 1 is 1. Multiply those, you get 2. So with 2 degrees of freedom to run a test of independence. Okay. Now, when you do this, if you want to do the formula, right, the observed minus expected squared over expected, you can, but it's not actually asking us to find each individual component. We just need to find the total chi-squared test statistics. So I'm just going to go ahead and just use the calculator to tell me this. All right, and we go back to our test. Remember, we're using the one that's not goodness of fit, so letter C. And this will give us our chi-squared test statistic of 10.291. All right, so if I draw the curve, all right, with that skewed to the right, shading to the right, this p-value is 0.006. Now, whatever alpha you decide, I usually use 0.05. You can see this is a very small p-value, so our p-value is below 0.05, so I will reject the null hypothesis in favor of the alternative. So essentially, if you go back to your hypotheses, I do have enough evidence to say that there is an association between type of ad that's shown during the show and the children's choice of snack. So there is an association between type of ad and children's choice of snack. All right, and that's it for this one here for the chi-squared independence test. Now, you'll notice both of these free response questions were about chi-squared, just as like if you're watching this video, give you a quick little, hopefully a boost. One of the free response questions will ask you about a linear regression T interval. We've done a lot of practice with that on the multiple choice side, but just be prepared to show the mechanics of running a linear regression T interval. All right, good luck.